Okie dokie, we got the 6.4 lesson, logarithm functions. This is about the graphs. Our recap here is about finding an inverse. Now, if you don't remember how to find an inverse, well, here's your steps. First step is to swap x and y. The second step is to resolve for y. And the third step is notation. Okay. Usually we use the form f to the negative first, or the notation. I'm tired, can't talk. Anyways, that is read as the inverse of f of x. So find the inverse of 3x squared minus 5, provided x is greater than or equal to 0. Now, this little provided part is a domain restriction, because if you thought about 3x squared minus 5, it'd look like that. And that just throws away that stuff over there, throws away the left-hand side. Anyways, our first step is to swap x and y. Do remember, don't be the kid who doesn't get that that is y, and that y becomes an x. And so we do our swapping. We have x equals 3y squared minus 5. Now we go through the process of resolving. Remember, you're trying to get at this little guy right here, so we're going to add 5 to both sides. X plus 5 is thrice y squared. Now we're going to divide by 3. So x plus 5 all over 3 is y squared. The opposite of squaring is a square root symbol, right? So the square root of x plus 5 over 3 is my y value, and I'll just go ahead and say that is the inverse of f of x. All right, some other recap stuff. Without technology, what is log base 3 of 3? That's a big deal because we're doing graphing today. It is a big deal. So the question this is asking is what power of 3, which is the base, that little 3 is the base, equals 3, which is the argument. Okay? And the answer is 1. 3 to the first is 3. All right, what is log base e of 1? That says what power of the base e is equal to the argument 1. So I know and you know that anything to the 0th power is 1. So the answer is 0. There's a reason we're talking about that here. It's because graphing. Those are easy things to figure out. What is a logarithm? A logarithm is the inverse of an exponential function. What do inverses swap again? They swap domain and range. Domain is x and range y, or input and output. Wouldn't kill you to know that. Since x and y get swapped, if an exponential function has a horizontal asymptote at y equals 6, so for those of you who have no idea what a horizontal asymptote is, a horizontal asymptote is a horizontal line that you cannot cross. We'll just say that's y equals 2. Now, if they get swapped, then the logarithm would not have a horizontal, because if we swapped x and y, we'd have x equals 2. But this was 6. Let me just say that's y equals 6 to make this x equals 6, just for the context of the problem. Forgive me, I'm tired and have a headache. Normal. But this is vertical. It would have a vertical asymptote at x equals 6. All right. Now, something old. Graph 2 times 3 raised to the x minus 1 plus 3 and her inverse, which don't worry about how I came up with the inverse. Don't. We'll get there. But graph that function's inverse. So let's graph that function. We have the plus 3. That plus 3, we're going to shift the graph up 3, and that is the horizontal asymptote. She's at y equals 3. We have the right one because it says x minus 1. And that right one is a good place to make a table. 0, 1, and 2 are the numbers I'm going to use. If I plug in a 0, I'd have 2 times 3 to the negative first plus 3. Now, 3 to the negative first is a third. So I have 2 times a third plus 3, which is, 3 and 2/3. But since we're graphing, it's about 3.67. So I contain 0 and then 3.67. Notice it's above the horizontal asymptote. That's a big deal. If I plug in a 1, I'd have 1 minus 1. I'd have 2 times 3 to the 0. And then add 3. Now 3 to the 0 is 1, so it's really just 2 plus 3, which is 5. If I plug in a 2, my exponent becomes 1. And that's 6 plus 3, which is 9. So 1, 5 and then 2, 9, which this grid doesn't go that far. It goes 7, 9 would be about up here. And there she is, because I memorized y equals a times b to the x, which from your perspective would look something like this, right? All right, domain of that thing, negative to infinity. The range, the low y value gets eerily close to 3, but not quite there. And then it rises to infinity as it moves right. Now, our inverse is going to swap x and y. So instead of having 2 3.67, I would have, sorry, instead of having 0 3.67, I would have 3.670. Let's use the correct notation, the inverse of f of x. Instead of 1, 5, I'd have 5, 1. Instead of 2, 9, I'd have 9, 2. What if this grid has enough room for 9, 2? 4, 8, 9. There she is. 5, 1. 1, 2, 3, 4, 5, 1. And in 0, 3.67, be about right there. Now, she does not have a horizontal asymptote. This y equals 3 becomes x equals 3. And that is the vertical line that the logarithm cannot pass. And here's an oldie but goodie. All inverses are symmetrical with the line y equals x. This is the line that the thing was flipped over. Maybe you can visualize that we took it and we flipped it over that line. The domain of the logarithm is 3 to infinity. Notice that inverses swap domain and range. The range falls forever, rises forever. Negative to infinity. Easy peasy lemon squeezy. All right, some old review here. The mother function for all exponentials is f of x equals a times b to the x. It contains the points 0a and then 1 comma ab. So 0a is contained and 1ab is contained. And you have to label those points because this is an xy axis with numbers. And we had 1, so obviously I went over 1 unit. But I don't know what a times b is because it's somewhat abstract. And she has a horizontal asymptote at y equals 0. And the default is the growth model, something like that. Domain is negative to infinity, and the range here would be 0 to infinity with a horizontal asymptote at y equals 0. Another function for all logarithms is f of x equals log base b of x, and she contains the points 1, 0, and then she also contains b comma 1. And I'll explain that later, but that mother function has those points. She contains a 1, 0, and then she contains some other point, which I'm going to put off here to the side, as b comma 1. And you have to label that point because you're not counting by b's on the x-axis. Instead of a horizontal asymptote, she is in possession of a vertical asymptote, and she will not cross it. I'm going to go ahead and circle that r because that is what logarithms look like. They look like r's. So she's going to come in from the right side and run left. She's going to get close to that asymptote, and then she's just going to fall forever. And your TI-84 does not graph these properly. The domain is 0 to infinity. The range is negative a to infinity. Notice, look. See how they swapped? Because they're what to each other? Inverses. And she has vertical asymptote at x equals 0. Easy peasy lemon squeezy. BRB taking a break. All right, so we're supposed to graph this thing. First, we're supposed to identify the transformations. You see that negative symbol? That is a vertical reflection. You see that too? I do. That's a vertical stretch with a factor of 2. You see that x minus 3? That's a right 3. And do you see that plus 4? That's an up 4. If you've been doing what you're supposed to be doing, all of that is so easy. You already know it. Now, it's an exponential because it has an exponent, which means its domain is going to be negative infinity to positive infinity. Its range is probably related to that plus 4, but we're not going to write that one because this one has a reflection, and that's a big deal. Anyways, we have our right 3. We have our up 4. And let's start making a table. We went right 3, so let's put a 3 in there, a 2 in there, and a 4 in there. Now, E is about 2.72. So I might do that in my head. I might not. I might push buttons in a TI-84. We'll find out. So if I plug in a 2, I have a negative 1. So that's going to be 2 times e to the negative first and add 4. And I don't feel like calculating what 1 over 2.72 is. I don't want to. I'm too tired. And I don't know any sane person that would unless they just had some free time, to be honest with you. I mean, it's not that hard to do. Well, if you know how to do it. Anyways, she's 3.26 or so, which is about as far as I care to go out for graphing. You plug in a 3, that exponent becomes a 0, right? So negative 2 times e to the 0, and then add 4. Well, e to the 0 is 1. The negative 2 plus 4 is 2. If you plug in a 4, that becomes a 1. So negative 2 times e plus 4. Now, e is ridiculously close to 2.72. So I multiply that by 2. I have 5.44. And it's negative because there's negative. So negative 5.44 plus 4 is negative 1.44. And there's my points. 2, 3.26, about right in that neighborhood. 3, 2, and then 4, negative 1.44. Now, why does she look this way? Because, well, if the plus sign wasn't there, she'd look like this. This one has been reflected. That's why she looks the way she does. And this is why I held off on writing the range. Because when we talk about range, the y values, we talk about the small y value followed by the high y value. So the small y value is negative infinity, and the high y value is just redonkulously close to 4, but it never hits 4. Horizontal asymptote was still y equals 4, the line that I did not cross. All right, now getting on to logarithms. Graph each function, identify the domain and range, list any intercepts or asymptotes, describe the end behavior. So good old freehanding graph. Now this is a natural log, which is a log base e of x. And if you'll think about, well, and we'll just make a table to reinforce it, but we're going to plug in two things. We're going to plug in a 1. So this is going to become log base e of 1, which says what power of e equals 1? And the answer to that is 0. And we're also going to plug in the base, which is e, because it's easy to do. A log base e of e says what power of e creates e, and the answer to that, sorry, this is 0. The answer to that is 1. I wrote 0 down here, but I wrote 1 up there, weird. So I want you to kind of reinforce this with the idea of all logarithms, unless a transformation has happened, contain 1, 0, and then the base 1. So 1, 0 is on my menu. And e, which is roughly 2.72, 2, 3, 1, is also on my menu. Make sure I label that one. That's e comma 1. Now, it is a logarithm. It has a vertical asymptote at x equals 0. So that needs to be drawn in. I cannot cross it. It is a logarithm. It looks like an R. And there is the graph of my logarithm. Domain for this particular dude. Domain is 0 to infinity. I almost wrote it wrong. And the range is negative a to infinity. It talks about end behavior, not list any intercepts. It does have an x-intercept. The x-intercept's at 1, 0. Asymptotes. That one was also at x equals 0. And end behavior. So as x runs right to infinity, the y value climbs. Y approaches infinity. As x approaches 0, however, because it can't go to negative a, as x approaches 0, y approaches negative infinity. Look for little things like that. Like EOC might talk about stuff like that. I mean, it's just part of how you're expected to learn how to think. B, we have a log base 3 of x, so we're going to make a table here. And hopefully you understand why I'm plugging in the numbers here. I'm going to let one of my x values be a 3. I'll let my x values be 1 and a 3. Because if I'm a 1, I'm a log base 3 of 1. What power of 3 creates a 1? The 0th power. If I'm a 3, I have log base 3 of 3. What power of 3 creates a 3? The answer is 1. So it's a lot like the last one. I contain 1, 0 again. And then I contain 3, 1. 2, 3, 1. I have a vertical asymptote right here at x equals 0. Could have swore I changed colors. There's my asymptote, x equals 0. Logarithms look like r's. And everything is the same. The domain is still 0 to infinity. The range is negative to infinity. The x-intercept still at 1, 0. The asymptote the same, and behavior is the same. Moving forward, graph this function. Log base 2 of x plus 3 minus 4. So she has some transformations. She has a left 3 down 4 transformation. And the left 3 is actually the big deal, because the left 3, the x equals negative 3, is the VA, the vertical asymptote. The minus 4, not a big deal. But she will contain this point right here. She should. The table here, log base 2 of x plus 3 minus 4. So you got to do a little math to think about the easy numbers to plug in. One of the easy numbers to plug in is going to be negative 1. Because I've got that note over here. The other thing that's easy to get would be, I forgot where I was, sorry. I'm doing this down here. This will make the argument be 2. So if I plug in a negative 1, I have a log base 2. Negative 1 plus 3 is 2 minus 4. If the base matches the argument, the answer is 1. And 1 minus 4 is negative 3. So I've got the point negative 1, negative 3. Now, what was the other thing I wanted to happen? I wanted the interior to become 1. So if the interior is 1, and I set x plus 3 equals 1, I get an x value of negative 2. That's the other easy guy to plug in. If I plug in a negative 2, I have a log base 2 of 1 and then minus 4. Log base 2 of 1 is going to be 0, and 0 minus 4 is negative 4. So back to fall 4, I told you it would have that point. I know a thing or two about these. And there you go. There's your logarithm. Her domain is negative 3 to the right. Man, forgive me, I just got disoriented. The range is negative infinity to infinity. All logarithms have a domain of negative infinity to positive infinity. All right, I'm going to take a small break, get over this disorientation. Be right back. All right. Starting inverses. First step, swap x and y. If you see f of x, you literally get the f out of it. So x is going to be 10 raised to the x plus 1 and then plus 4. Isolate the exponential or logarithm. Always isolate. So we're going to subtract 4 from both sides. And now that the base has been isolated, label your pieces. Base, that's an exponent, and that's an argument. We're going to have a log whose base is 10, whose argument is x minus 4, and equals x plus 1. That's supposed to be a y, isn't it? I forgot to make that a y. Equals x plus 1. Hold on. Let me go through that process again. We're going to have x minus 4 equals 10 to the x plus 1. Base, exponent, argument. I was writing stuff down, and I'm still doing it wrong because I'm still dizzy. All right, now I'm ready. I'm going to have a logarithm whose base is 10. Her argument is x minus 4. Remember, the goal was to resolve for y here. And that got y on the level. Subtract 1 and you're done. Now, a log base 10 is understood. You're just going to have log x minus 4 and then take away 1. This is called f of x. There's your inverse. Easy peasy lemon squeezy. All right, next one. We got g of x. We're going to get the g out. X is log base 7 of y plus 5 and then minus 3. We're going to isolate this logarithm, so we're going to add 3 to both sides. X plus 3 is a log base 7 of y plus 5. We're going to identify our pieces. 7 is a base. That means that y plus 5 is her argument, which means that this is going to be my exponential material. So 7 gets raised to the x plus 3, which is going to equal y plus 5. We're going to subtract 5 from both sides. Don't think 7 minus 5. It's 7 to the x plus 3 minus 5. Don't be that kid. And that's my inverse. All right, last one. Thank God, because I don't think I have another one in me. Given f of x is equal to log understood base of 10 raised to the x minus 2 plus 3, find her inverse and graph both f of x and her inverse and state each function's domain, range, and asymptotes. I'm actually going to do this first because it's easier to graph an exponential than it is a logarithm to some degree. So let's do that first. Let's do the inverse. X is going to be equal to log base 10 of y minus 2 and then plus 3. We're going to go through the isolation process. X minus 3 equals a log base 10 of y minus 2. Base argument exponent. 10 to the x minus 3 is y minus 2. And then 10 to the x minus 3 plus 2 must be my inverse of f of x. Yeah, that is easier to graph, believe it or not. I'm only going to use 2 points because the bell's about to ring. I'm going to plug a 3 in. If I plug a 3 in, that becomes 0. 10 to the first is 10. Add 2, you get 12. And I'm also going to plug a 4 in. And I did that wrong. 10 to the 0 is 1. 1 plus 2 is 3. If I plug a 4 in, I have 10 to the first, which is 10 plus 2 is 12. Those are my 2 points I'm going to use. So I have 3, 3, and I have 4, 12, which is going to be, off the grid up here somewhere. 4, 12. Now, she was a shift up 3. Oh, hold on. She was a shift up 2. It was plus 2. That's a big deal to that thing because that is the horizontal asymptote, and then she's just going to rise. Now, when you talk about your inverse, we're just going to swap those points. 3, 3 stays 3, 3. All right? 4, 12 becomes 12, 4. This grid does not go out that far. It goes out to 10, so 12, 4 would be up about right here. And we still have 3, 3. It'll look something like this. Now, there's a reason I'm actually stopping right here. It's because that x minus 2 is a shift right 2, and that, boys and girls, is her vertical asymptote. She's at x equals 2. The other guy had a horizontal asymptote at y equals 2. That's why they never crossed it. And by the way, the line of symmetry for all functions and their inverses is y equals x. Doing pre-calc right now, it just occurred to me that we could probably, well, maybe not. They kind of look like hyperbolas, but they're not. That was just a stupid thought. Anywho, there's 6, 5. Didn't have time for domain and range. You know those already.